Inventory alone is never enough. The importance of persistent data to your CMDB and SAM. Maybe this sounds familiar to you. Data in a CMDB is not accurate because computers are missing, manual updates are required, so that means a lot of manual work for your colleagues. So you have no reliable foundation for compliance reports and license management. You cannot start cloud transition projects or transitions within the data center because you have no foundation, and you can also not benefit from cost saving. Wouldn't it be nice to have a GPS for your IT landscape that always tells you reliably and persistently where you are, what assets, CIs, services, applications, and devices you have in your infrastructure, and how everything is connected? That's something Matrix 42 can deliver. So, of course, we have traditional active discovery. So that's the inventory scan that runs once a day, either through a remote connection to the target system or through an agent installed on the target system. But sometimes we cannot get everything we need with just active discovery, and that's why we need persistent discovery. Let's have a look at some examples here. In this case, a web server is running on an ASX hypervisor. So of course that's covered by active discovery because they usually run 24/7. And it's also covered by persistent discovery, which is continuously looking at network traffic to detect changes in your environment. But let's have another look here on this example. There's a jump host used by an external support team. So whenever there's an issue, they log in via VPN and they power up the jump host and then connect to the system. So this system is maybe started once or twice a month. So a traditional active discovery will never get it because it only runs once a day. The persistent discovery will automatically detect, okay, this jump host has been powered up and will be added to the CMDB or updated. Let's have a look at another example here about web server load balancing. So maybe web server A and B are running 24/7, but if there's high load, web server C will also be booted up. And if we only have active discovery, web server C will never show in our CMDB as being active because it only runs once a day. But with persistent discovery, we will always get information if web server C has been powered up and used. And finally, another example for batch jobs. So when an application server runs batch jobs every night, sending, for example, reports to partners. This is only some seconds or minutes what it takes to run the batch jobs. So it will not be part of the active discovery, but it will be covered by the persistent discovery. Our solution for this persistent discovery is called Firescope SDDM, which stands for Secure Discovery and Dependency Mapping, which is a cloud-based solution. And on-prem or in the cloud, you can have so-called edge devices, which run as a VM or on a physical system, which continuously monitor the network traffic, either through network tap and port mirroring or promiscuous mode, or what is always recommended, if switches support S-Flow or NetFlow protocols, we can just get a summary of the network traffic which is collected by the edge device. In addition to this, we can also do active discovery with SNMP, WMI, SSH, and Nmap for the different operating systems. So this data is automatically normalized and deduplicated in the cloud, and then you can use the console to analyze the data, create reports, or propagate your ITSM system, CMDB, and SAM. We also support other systems, not just Matrix 42. For example, we have interfaces to ServiceNow and Chervil. What is the impact of incomplete data on SAM compliance? If a new server is not detected by active discovery or inventory, this could be an issue. Maybe the server was not up when the scan was running, so it scanned the network, but the server was not reachable. So it's not part of the daily inventory scan, no software detected, and as a consequence, there will be missing license requirements in your SAM. So finally, you have a non-compliance situation. Matrix 42 can automatically discover new systems in your network by persistent scanning, and it can create a task if a new server is detected, so you can decide if this is a threat or maybe a change gone wrong in your environment, so you need to add the server to your daily inventory scan. This could look like this. So this is the Matrix 42 service desk, and we have a ticket here with the summary rogue device detected, which means this new server has been detected by the persistent scanning. It talked to one of my critical business services, which is here right in the middle, and so it automatically created this ticket called rogue device detected. So now I can either update my CMDB or add the system to the inventory scan or forward this to my security team. Another impact of incomplete data on SAM compliance is related to indirect usage. It is always hard to track indirect usage, which is when devices are accessing, for example, a SQL database indirectly. So that means via an app server or a gateway. A quick example, there's an iPad, smartphone, or Windows system that connects to a web server, and the web server internally connects to an application server, which is then connecting to a database. So on the bottom line, you need a device cal for the database for the iPad, smartphone, or computer out there. So cals are required for this kind of communication, and sometimes the communication and the dependencies are not clear. And so as a consequence, the license requirements will not be detected and you have non-compliance. Another interesting factor is that some systems cannot be scanned with normal tools because that's appliances with a non-standard operating system or Internet of Things devices that do not support traditional inventory scanning. Matrix 42 can auto-detect business services and all the dependencies by just listening to the network traffic. And it can also display all the dependencies in a graphical view. This is an example for a business service mapped in a graphical view. So we have various CIs here, and we can see the communication between the devices. So the blue arrows means there's network communication with the ports right next to the arrows. So that's in our baseline map, that's known communication. The violet arrows mean hypervisor connections, so that's a hypervisor with a host running, with a guest running on the host. And these are storage connections, the yellow arrows. So this is a filer. It's used by this ESX system, for example. We can also detect clusters, like here. And if there's any change in this baseline map, for example, these dotted lines indicate that there used to be network communication, which is now right now not happening. So we can analyze why there's no communication. So it's deviating from the baseline map. There could also be blue dotted lines, which means there's a new communication detected, which needs to be evaluated. And this view can also be used to detect indirect usage. We have a quick example here. This web server is talking to this MongoDB. So if cals are required for the MongoDB, it can automatically create a license requirement. But this communication is a little harder to find. So we have this web server talking to the Mongo 3 database, which is also talking to Mongo 2. Maybe this is also relevant for indirect license usage if this web server is talking in an indirect way to this Mongo 2 DB. So this is something we can detect from this graphical view. If this sounds interesting, please contact your Matrix 42 partner or your Matrix 42 account manager, or simply send an email to info@matrix42.com for more information or a trial.